So what we did in our previous video was to consider the substitution technique as a sort of recognition problem. In this video we will take a more formal approach and we will consider the problem of computing the primitive of the function little f of a function h of x multiplied by the derivative of this function h of x. And the idea is to replace this function h of x by a new variable u. So what is the first step that you have to take? So if u becomes h of x, then what we get in any case is that if we compute the derivative of h of x to x, then we have the function h prime of x. And if we substitute h of x by u and take the x to the right side, we get that du is equal to h prime of x dx. Okay, now we will use this to substitute h of x by u. So what do we get? Now, what we did is that we could rewrite du as h prime of x dx, so we can substitute that part by du. We substitute h of x by u, and what we end up with is to compute the primitive of fu du. Now, clearly little f has some primitive function big F, and so we get capital F of u plus a constant c. Now again we have to go back to our original variable x, so we substitute u again by h of x, and then we get that our required primitive is now equal to this f of u, capital F of u plus the constant c, and substituting back u h of x instead of u, we get capital F of h of x plus constant c. So we'll discuss one example. So we want to compute the primitive of the function x divided by square root of x squared plus 1 dx. Now, problem is of course in this square root part, because in general 1 over square root can be integrated by increasing the power by 1, so we get square root. But the problem is this function x squared. So what we try, of course we can approach this as in the same way as the previous video, but now we just think, well, this x squared plus 1 is complicated, we substitute it by u. So what do we get? Now we write u is equal to x squared plus 1, and so then we get that if we want to replace the variable x by variable u, that we get du is equal to the derivative of x squared plus 1 to x, which is 2x, dx. Okay, let us substitute. We do our substitution, so we get that this original problem now becomes, well, we substitute x squared plus 1 by u, so we get square root of u in the denominator. X dx is, well, let us compare to du. Du is 2 times x dx, so x dx is 1/2 times du. And so what we have to do is to integrate u to the power minus half multiplied by 1/2, and this is equal to, well, very easy, the power increases by 1, so we get u to the power 1 plus 1/2, and if we differentiate we get exactly this term 1/2 in front. And again, substituting u x squared plus 1 back, we get that the required integral is equal to x squared plus 1 to the power 1/2 plus a constant, and if you like to write square roots, we get square root of x squared plus 1 plus a constant c.